Is it audible? L50. Answer me.
Yes, sir.
So in the previous class, we have started the condition for discrete time signal periodic. Okay, discrete time signal to be periodic. So the formula to find out the time period of the individual signal, capital N equal to 2 pi by omega naught dot m, where m is the smallest positive integer such that the capital N became a rational number. So two problems we solved in the previous class, cos 0.1 pi n. So 2 pi by omega naught. So 2 pi by 0.1 pi will be cancelled. 2 divided by 0.1, 20. So we have to select smallest positive integer value. That is, in this case, I am selecting m equal to 1. Okay. So 20, smallest positive integer, 20. So this signal is a periodic signal. Once you find the capital N value, after selecting the appropriate, the positive smallest integer value m, if there is no pi terms, there is no root terms in the capital N equation, then the discrete time signal is a periodic signal. Okay. So another example I had given. Suppose 0.1 n, pi term is not there in the cos function. So 2 pi by omega naught, 2 pi by 0.1, so 20 pi. So now if you select any value for capital M, if you select 1, 2, 3, whatever it may be, so these pi terms will not cancel. Understood? So for any value of M, for any value of M, M is the smallest positive integer only. Okay, you have to select 1, 2, 3, 4, 5, and so on. For any value of M, the N have pi term. Okay. Therefore, this signal is aperiodic signal. Therefore, this signal is aperiodic signal. So we know the discrete time signal to be periodic. The capital N value should be the whole number, not the decimal point. See here. The capital N may be 1 or 2, 3. In this example, 5 samples forms a one group. Okay. So while plotting the discrete time signal, decimal point is not allowed. So this is the procedure. In continuous time signal, individual sine, cos, complex exponential is always periodic, irrespective of your capital T value. If more than one signal mixed, then you have to follow the procedure. But in discrete time signal, all individual signal also we have to check the capital N value. In the capital N value, after selecting the smallest positive integer m, if any root terms or pi terms available, then the signal is aperiodic signal. We'll solve one more problem. Sine 6 pi by 7 n plus 1. Check whether the signal is periodic or not. Okay. So the formula for fundamental time period of a discrete time periodic signal, n equal to 2 pi by omega naught. 2 pi by omega naught value here 6 pi by 7. Sine omega naught n plus theta. Forget about theta. So we need this omega value. This is the omega naught. So 6 pi by 7. Pi will be cancelled. 2 divided by 6. 7 goes on top. 14 by 6. Okay. Dot m. Dot m. First simplify this 14 by 6. 7 2s are 14. 3 2s are 16. Dot m. Now select the m value, smallest positive integer, such that the capital N should be the rational number. So in this example, what value we have to select? I need n is a whole
Sorry.
m equal to, I think he answered 3, correct?
Yes, sir.
So we have to select m is 3. In this example, we have to select m is 3. So the 3 will be cancelled. That's all. Okay. Smallest term. We should not select 6 or 9 and so on. Smallest possible integer value we have to select. So if we select m equal to 3, 3 will be cancelled, n equal to 7. Therefore, the signal is periodic signal. The signal is periodic signal with the fundamental time period n equal to 7 seconds. Okay. In this way, we have to select the m value. Next, problem number 4. X of n. X of n equal to e power j 6 pi n. Okay. X of n equal to e power j 6 pi n. So this is similar to your e power j omega naught n. Discrete time complex exponential. The formula is same. Capital N equal to 2 pi by omega naught into m. So 2 pi divided by omega naught 6 pi. 6 pi dot m. So pi cancel. So 1, 2, 3, 2, sir. M. Okay. Now we have to select m value. So we have to select the m value. So pi problem. Okay. 6 pi n. Okay. Right. Now what value we have to select again? N should be a rational number. So this denominator part we have to cancel. Okay. Just understand. Simple thing. So we have to select the m value such that the denominator term should be cancelled so that n will be the rational number. So if we select m equal to 3, so 3 will be cancelled, n equal to 1 second. Okay. So for m equal to 3, your capital N value is 1. There is no root terms or pi terms are not there. Therefore, the signal is periodic signal. Therefore, the signal is periodic signal. The n value 1 second. That is fundamental time period of the signal. Now, two combinations, two components are available. E power j 2 pi by 3n plus e power j 3 pi by 4n. Okay. Now check whether this signal is periodic signal or not. Whether the given discrete time signal is periodic signal or not. Okay. So what is the procedure? If a signal having more than one component, we have to find out individual component time period of the signal, individual time period of the each and every component. Only two components available here. So n1 equal to 2 pi by omega naught, that is 2 pi by 3 dot m. N2 equal to 2 pi divided by 3 pi by 4 dot m. So what is n1 value? 2 pi will be cancelled. You will get 3 dot m. What is n2 value? Pi term cancel. 4 into 2, 8 by 3 m. So smallest positive integer, we can select m equal to 1. So you will get n equal to 3. The smallest positive integer for m. So that you have to cancel this denominator term. So if you select m equal to 3, 3 will be cancelled. So n equal to 8. Okay. So n1 3, n2 8. n1 3, n2 8. Okay. Now Step 2, find the ratio between n1 to n2, 3 by 8. Therefore, the ratio between n1 to n2 does not have any root terms or pi terms. It's completely the ratio between two rational numbers. Therefore, the given signal is a periodic signal. Periodic signal. What is the fundamental time period of the signal? LCM of n1, n2. LCM of n1, n2. Only two components are present. So if we find the LCM or cross multiply these two, 8 times or n1 equal to 3 times of n2. So your fundamental time period, capital N, you may calculate LCM of n1, n2. That will be equal to, if we cross multiply these terms, these two expressions, 8n1 equal to 3n2. You will get same answer. So 8 terms of n1 equal to 3. Or 3 times of n2, 3 into 8. So 8 times of 3, 3 times of 8, you will get same result. The fundamental time period is 24 seconds. Okay. So in discrete time signal, individual signals we have solved. And if two component signal is given, then what is the procedure? Problem number 6. Problem number 6. Suppose if the discrete time signal x of n given as 12 cos of 20n. 12 cos of 20n. Okay. Check the signal is periodic or not. So already I told you, in the discrete time signal, if individual component is given, check your cos term. If there is any pi terms, then the pi will be cancelled. If there is no pi terms, while calculating the capital N, that is 2 pi by omega naught, that is 2 pi by your 20 dot m. Okay. So 110. So pi by 10m. So if you select any value for m, anyway pi terms will not cancel. Okay. There is no possibilities of cancellation of this pi. Therefore, this is not a periodic signal. This is a periodic signal. Okay. Pi terms is or root terms. Please remember, while calculating the fundamental time period of a given discrete time signal, the capital N value should not have any root terms or pi terms. Then only it is periodic. If more than one component given, then we have to check n1 to n2 ratio, n1 to n3 ratio. All the ratio must be the rational number. And the fundamental time period is LCM of n1, n2, n3 and so on. Okay. So this is some other type of problem. Suppose two signals are multiplication, available in the form of multiplication. Cos pi by 2n, cos pi by 2n, dot cos pi by 4n. Now how to solve this? First you have to expand these expressions using the trigonometric formula, cos A, cos B formula. Okay. Then you will get the individual component. After that only we need to apply the procedure. So cos A, cos B, cos A plus B, cos pi by 2 plus pi by 4. Okay. Cos A plus B plus cos A minus B plus cos A minus B divided by 2. Okay. So 1 by 2 cos 3 pi by 4n first term plus cos pi by 4n. Okay. Or 1 by 2 cos of 3 pi by 4n plus 1 by 2 cos of pi by 4n. Okay. So now it has two components, half cos 3 pi by 4n plus half cos pi by 4n. Now you apply the procedure. Okay. So don't apply your n1, n2 directly on the given problem. You must expand the equations so that you will get the expression like this, signal 1 plus signal 2 and so on. Okay. Now what is n1? Fundamental time period of the first component, 2 pi divided by 3 pi by 4 dot m. n2 equal to 2 pi divided by pi by 4 dot m. So this pi term cancel, 4 times of 2, 8 by 3 m. n2 equal to this pi term cancel, 4 times of 2, 8 m. So smallest value of m. So if I select m equal to 3, the 3 will be cancelled. I'll get n1 equal to 8. The smallest positive integer m, I'm selecting m as 1. So 8.1 equal to 8. Okay. So n1, n2. Both are 8, 8. Okay. Now find the ratio between n1 to n2. 8 by 8. That is 1. Okay. So n1 to n2 ratio, there is no root terms, pi terms in the final answer. Therefore, the given signal is periodic signal. Therefore, the given signal is periodic signal. So what is the fundamental time period of the signal? Capital N equal to LCM of n1 comma n2. LCM of n1 comma n2. Or you can just cross multiply n1 by n2. That is 1 by 1. So n represent either n1 or n2. 1 dot n1 equal to 1 dot n2. So n equal to 8 seconds. Okay. So in this example, the fundamental time period of the signal equal to 8 seconds. So individual signal we discussed, and complex exponential. If two components present in the signal, if the signal available in the form of multiplication, then we have to use the trigonometric formula to expand the signal first in the form of x of t equal to x1 plus x2 plus x3 and so on. Okay. So then apply the procedure. The last problem, discrete time signal periodic. Problem number 8. Problem number 8. Identify whether the given signal is periodic signal or aperiodic signal. X of n equal to sine pi by 8n minus 2 cos pi by 2n plus pi by 6 plus sine of pi by 8n. Okay. 3 components. Sine function, second one is cos of something, third one is sine of something. So find N1, find N2, find N3, and N1 by N2 ratio, N1 by N3 ratio. So N1, 2 pi by 8 dot m. So pi will be cancelled, 16 dot m. N2. So this is cos omega naught n plus theta, this phase information. So we have to select omega naught only. So 2 pi by 2 dot m. Pi will be cancelled, you will get 4 dot m. N3 equal to 2 pi by omega naught, that is pi by 8 dot m. Pi will be cancelled, 16 dot m. So in all these N1, N2, N3, smallest positive integer m is 1 only. So 1 into 16, 1 into 4, 1 into 16. Because there is no denominator term. If denominator values are available, then we have to select m in such a way to cancel that denominator. So N1 equal to 16, N2 equal to 4, N3 equal to 16. Okay. So ratio between N1 to N2, step 2, 16 by 4, 4 or 4 by 1. The ratio between N1 to N3, 16 by 16 equal to 1 by 1. So N1 to N2, N1 to N3, the ratio are between two rational number only. There is no root terms or there is no pi terms. Therefore, the given signal is periodic signal. Therefore, the given signal is periodic signal. So how to find the fundamental time period of the signal? The fundamental time period of the signal n equal to LCM of n1, n2, n3, or LCM of denominators of all the ratio and then multiplied with n1. Okay, you can find the fundamental time period of the signal for this three component, either LCM of n1, n2, n3. LCM of 16, 4, 16. So what is the LCM? Least common multiplier for 16, 4, 16. What is the value? Take 2.
It's
1, 1. Okay. So 2 times of 2, 2, 2. N equal to 16 second. If N1, N2, N3 have the fractional value, then it will take some time. LCM of the fractional. So I explained in the previous classes. So LCM of numerator divided by HCF of denominator, highest common factor of denominator. Or shortcut method, LCM of denominators of all the ratios. So in this example, N1 to N2, N1 to N3, only two ratio. So this is the denominator, 1, 1. So LCM of denominator of all this ratio in this problem, 1, 1 only. So that is 1. So the fundamental time period n equal to this LCM value multiplied with n1. So what is n1? 16. 16.1 equal to 16. So this is alternate method to calculate fundamental time period of this. LCM of denominators of all the ratios. And the final result should be multiplied with n1. Or LCM of n1, n2, n3. Both will give same result. So the basic operations on signal and the periodic signal, aperiodic signal, how to check whether the given signal is periodic and aperiodic, and even signal, odd signal. Okay, so all are very important. Okay, so any doubt? Summarize the periodic and aperiodic concept. Continuous cases, discrete cases. Okay, continuous cases, discrete cases. All sine function, cos function, e power j function. Okay, that is e power j omega naught t. All individual sine, cos, e power j omega t. Individually always periodic. Then you have to write down the time period t equal to 2 pi by omega naught. Okay, but in dt signal, check n equal to 2 pi by omega naught into m. Okay, after selecting this m value, if n is a rational number, then only the given signal is periodic. Discrete. Okay, individual sine omega naught n, cos omega naught n, or e power j omega naught n given, we should not write all the signals are periodic like a continuous cases. Okay, you have to check the n value as per the formula. After selection of your small m, then if there is no pi terms and there is no root terms, then only it is periodic. It's for individual. If more than one component, the procedure is same for both. Okay, so we have to find out T1, T2, T3. There also N1, N2, N3, T1 to T2, T1 to T3. In discrete time signal, N1 to N2, N1 to N3. The ratio should not have any root terms, pi terms. Then only the signal is periodic. The fundamental time period equal to LCM of T1, T2, T3. Here LCM of N1, N2, N3. That procedure is same. So a small difference in the formula, that is M, smallest positive integer. So that the capital N should be a rational number. Okay. So are you clear about this concept? Any doubts? Shall we move to next topic?
Yes, sir.
Fine. Okay. So classifications of signal. Even signal, odd signal. Okay. Continuous time signal, discrete time signals. It's very fundamentals. Even signal and odd signal. Now periodic signal and aperiodic signal. Just be completed. Okay. Remaining three are energy and power signal, causal and non-causal signal, deterministic and random signal. So out of these three, the energy and power signal having the problems. Remaining two are just definitions only. So now in today's class, we will start which signals are energy signal and which are the signals are power signal. Basic definition and simple problems to identify whether the given signal is energy signal or power signal. Okay. Next, classifications of signal. energy or power signal. Energy and power signal. First, we will discuss the definition. Energy signal and power signal. So I'm explaining in shorter way. Continuous time signal formula, discrete time signal formula. So what is the formula for energy in continuous cases? So energy equal to integration minus infinite to infinite x of t modulus x of t square into dt joules. Okay. In discrete time signal, the formula for energy equal to summation n equal to minus infinite to infinite x of n, unit is joules. Okay. So remember the formula. To find energy of a given signal. Continuous cases, integration minus infinite to infinite. Actually, limit t tends to infinite, then integration minus t2 plus t. But anyway, in energy, we can substitute the infinite directly, no problem. The formula for power of a continuous time signal, power equal to limit t tends to infinite, 1 by 2t integration minus t2 plus t x of t whole square dt. Okay. So after simplifying these steps, at last we have to substitute t tends to infinite. We have to check whether there is a possibilities of cancellation of this t or not after the simplification. Okay. At last step, we have to substitute t tends to infinite. Similarly, for calculating power of a discrete time signal, limit n tends to infinite, 1 divided by 2n plus 1. Summation n equal to minus n to n x of n also. Unit is watts. The unit of the power is watts. And here also watts. Okay. So first remember the formula. How to find out energy of a continuous time signal, power of a continuous time signal, energy of the discrete time signal, energy of the power of the discrete time signal. Now how to identify the given signal is power signal. A signal is said to be a power signal. The power of the particular signal is finite. After finding the power, it should be the finite value. And energy of the particular signal should be infinite. Okay. Any given signal, using these two formula, we have to find out energy first and then power or power energy. Okay. Then check the status. Power must be finite for power signal. Energy must be infinite. Okay. So this is the condition for power signal. To identify energy signal, energy must be finite. Energy must be finite. And power equal to 0. Okay. So these are the condition to solve the problems. Okay. First of all, we have to remember the formula for continuous time power signal, continuous time power calculation, and energy calculation. And then discrete time signal, energy formula, power formula. Okay. After finding power of the signal, energy of the signal, check these two conditions. A signal to be a power signal, power must be finite, energy must be infinite. Okay. A signal to be an energy signal, energy must be finite, power must be zero. In most of the cases, your periodic signal, your periodic signal must be a power signal. Not all the signal, maximum cases. And your aperiodic signals must be the energy signal. We'll check using the formula. Okay. So periodic mean your sine t, cos t, and e power j will come, and e power jt, like this. These are all periodics. So if we apply this logic based on the condition, we'll get the same value. Power of the signal will be finite, energy of the signal is infinite after applying the formula. So this is a simple clue for you, but anyway, you have to go ahead with the formula. Aperiodic signal, suppose a exponential signal e power minus t, or e power minus t, some u of t plus 10, like that. Okay. So this signal most probably will be the energy signal. I'll repeat once again. Energy equal to modulus x of t square dt, integration minus infinite to infinite. Or some textbook, limit t tends to infinite minus t to t. Anyway, we have to substitute t tends to infinite, so I don't want to confuse for you. So you use this particular formula only, minus infinite to infinite directly. Power value 1 divided by 2t, integration minus t to t x of t square dt. After simplification of this, check the possibilities of cancellation of this capital T. At last, substitute t tends to infinite. Okay. So we solve one problem, you will get a clear idea. One simple problem only today I will solve. Identify whether the following signals are energy or power signal. X of t equal to e power minus 10t dot u of t. X of t equal to e power minus 10t dot u of t. What is the sketch for e power minus 10t? T equal to 0, e power 0, 1. Then e power minus t, so it may be the decreasing exponential this side. Negative value of t, minus 1, so minus into minus plus, so e power 10. Minus 2, minus into minus, e power 20. So in the negative value of t, you will get increasing exponential. What is the sketch for unit step signal? Okay, minus infinite to 0, 0, 0 to infinite, the magnitude 1. If you multiply these two signals, the resultant signal 0 multiplied this value 0. So you will get only the positives. E power minus 10t dot u of t. So minus infinite to 0, nothing is there. 0 to infinite, your function is e power minus 10t dot ut. So energy formula, as per the formula, minus infinite to infinite x of t modulus x of t whole square into dt. But in this particular problem, minus infinite to 0, no information available. So your integration limit changing from 0 to infinite. What is x of t? E power minus 10t dot u of t. U of t is 1. So e power minus 10t dot 1 dot square. Okay. So e power minus 10t square. That will be equal to 0 to infinite e power minus 20t into dt. Okay. So the formula for energy after simplification, integration 0 to infinite e power minus 20t dt. E power minus 20t divided by minus 20. We solve this. Then substitute the limit 0 to infinite. So minus 1 by 20 take outside. E power minus infinite. E power minus infinite 0. And minus e power 0 1. So minus into minus 1 1 by 20. 1 by 20 joules. For the given signal, if we apply the formula for energy, after sketching the signal, then we have to check the integration limit also. Finally, we have derived energy value is 1 by 20. Okay. Now check for power. Limit t tends to infinite 1 divided by 2t integration minus t to t x of t square dt. This is general formula. So in this example, 0 to t only the information available. The negative value of t, no value. So modify this expression. Limit t tends to infinite 1 divided by 2t integration 0 to t e power minus 20t dot dt. U of t value 1. So x of t e power minus 10t. So you know that e power a power b. That will be equal to e power ab or a power b power c. Then this will be equal to e power abc. So e power minus 10t whole square. Obviously, you will get e power minus 20t. Now solve this. Okay. And check for possibilities of cancellation of this t. At the final step, substitute t tends to infinite. So the limit t tends to infinite 1 by 2t e power minus 20t divided by minus 20. Correct? 0 to t. Okay. So substitute the value. Limit t tends to infinite 1 by 2t e power minus 20t e power minus 20 capital T divided by minus 20 minus of minus plus e power 0 1. Okay. So this particular t unable to cancel. This t is like that only. E power minus 20t. Okay. So no possibilities of cancellation of this t. Now if you substitute limit t tends to infinite, 1 by infinite, 1 divided by 2 times of infinite. So 1 by infinite equal to 0. 1 by infinite equal to 0, your total result will be 0 watts. So you have to substitute the t value at the last step. You have to check whether this result will cancel this t or not. Okay. If not, then final step 1 by infinite 0, 0 dot anything 0. You have to complete the problem like that. So for this particular problem, energy is 1 by 20. For the given problem, energy is 1 by 20. This is a finite value. Energy is a finite value. Power equal to 0 watts. Power equal to 0 watts. So whether this is energy signal or power signal, according to our definition. Energy finite, power 0. Therefore, the given signal is energy signal. Okay. So this condition is satisfied now. Therefore, the given signal is energy signal. Therefore, the given signal is energy signal. Okay. So like this, we'll be solving more problems in the next classes. How to identify whether the given signal is energy signal or power signal, or neither energy signal nor power signal. In some cases, both these conditions will not be satisfied. In that case, we have to write the comment like the given signal is neither energy signal nor power signal.